When analyzing categorical data from two independent populations, and you want to know whether the observed difference in their proportions is statistically significant or likely occurred by random chance, the z-test for two population proportions is used. In this z-test, the z-statistic, which is the standardized difference between the two sample proportions, measures how many standard errors the observed difference is away from the expected difference under the assumption that there is no difference in the population proportions. Under certain statistical assumptions, the z-statistic follows a standard normal distribution. Now, if the calculated z-statistic is more extreme than the critical value determined by the significance level, we conclude that there is a statistically significant difference between the two population proportions. This test has wide applications in various fields. For instance, in quality control, it compares the proportion of defective items from two manufacturing processes or assembly lines, and in pharmaceutical research, it compares the proportion of patients improving under a new treatment versus a placebo or standard treatment. In this video, we will use a 5-step hypothesis testing procedure to determine if a new antiseptic protocol works better than the standard protocol in reducing post-surgical infections. A research group investigated whether a new pre-surgical skin cleaning method was more effective at preventing infections than the standard method. They conducted a study involving 800 patients undergoing similar surgeries, randomly assigning 400 patients to receive the new protocol and 400 to receive the standard protocol. All patients were monitored for 30 days post-surgery to identify surgical site infections. The results showed that 24 patients in the new protocol group developed an infection, compared to 40 patients in the standard protocol group. In this scenario, the population consists of all patients undergoing similar surgeries. The parameter of interest is the difference between the population proportions of patients developing a surgical site infection under the new protocol versus the standard protocol. The claim is that the new antiseptic protocol is more effective than the standard protocol in reducing post-surgical infections. Since this claim does not include equality, it becomes our alternative hypothesis. The null hypothesis, therefore, represents the opposite. To ensure the validity of the two-proportion z-test, we must verify several key assumptions. First, the data should be collected from random sampling or a randomized experimental design, ensuring the groups are representative of the populations. Second, the two groups being compared must be independent of each other, and the individual observations within each group must also be independent. Third, the sample sizes must be sufficiently large to support the normality approximation. This is typically checked using the success-failure condition, that is, both groups must show at least 10 successes and at least 10 failures. Finally, if sampling without replacement from a finite population, the 10% condition should hold, that is, each sample size should be no more than 10% of the respective population. In this scenario, the random assignment of patients to each group satisfies the randomization requirement and ensures independence between the groups. The success-failure condition is satisfied for each group, and independence within groups is assumed. To find the standardized difference between the two sample proportions, we calculate the z-statistic using the following formula. Where P1 and P2 are the sample proportions of patients who developed an infection under the new and standard protocols, respectively. P bar is the pooled sample proportion calculated by combining both groups. Inserting these values in the formula, we get a z-statistic of approximately -2.085. This z-statistic indicates that the observed difference between two sample proportions is 2.085 standard errors below the expected difference of 0, assuming no difference between the protocols. Next, we will use the critical value approach to decide whether to reject or fail to reject the null hypothesis. The critical value approach defines a rejection region based on the significance level, the type of test, that is one-tailed or two-tailed, and the test statistic. We reject the null hypothesis if the test statistic falls within this region. Our test is left-tailed because the alternative hypothesis uses a less than sign. With a significance level of 0.05, we find the critical value from the z-table to be -1.645. The rejection region thus consists of all z-values less than -1.645. Since our z-statistic falls within the rejection region, we reject the null hypothesis at the 5% significance level. Therefore, at a 5% significance level, we conclude that the new antiseptic protocol is significantly more effective than the standard protocol in reducing post-surgical infections. If you'd like to test your knowledge on this topic, be sure to check the quiz link in the description below or visit our community page. Thanks for watching. Please like, comment, and subscribe for more statistics content.